Okay, I'm back with question 5. Alright, actually I was covering, I think, deceleration a bit earlier, but the graph was quite messy, so I cleared it and I'll just discuss it quickly here. Alright, remember that deceleration is actually an English word. Alright, it's not actually a physics term. The meaning of deceleration is actually slowing down. Alright, so when we look at deceleration, actually I just want to find the magnitude of the acceleration when something is slowing down. That's the meaning of deceleration when they ask for calculation of deceleration. If I want a deceleration here, okay, I remind myself that since actually it's just the magnitude of the acceleration when I'm slowing down, I want to find the gradient at this point. And you'll find that actually this whole line has the same gradient. Right, so I can just take these 2 points over here, which happen to be 150 and 5. Alright, and then here is 250. Alright, and the y-axis is 0. Right, so normally when I find gradient, I take y2 minus y1, 0 minus 5, divided by x2 minus x1, which is 250 minus 150, and I believe that's how they calculated here, right? 0 minus 5, 250 minus 150, right? So that's how they calculated acceleration, and you'll find that acceleration is negative, which actually is correct because can you see that the gradient of this graph is negative? Okay, I remind you that this is a positive gradient. Alright, so you can see that this is a positive gradient. This is 0 gradient. This is 0 gradient. Anything that looks like that is actually a negative gradient. So I would expect that if I calculated the gradient of this part over here, I should get a negative answer. Right? If I get a positive answer, something is wrong. Right? So if I look at this answer that's negative, yeah, that's no problem. Alright, I know that this actually is likely to be the correct answer. Okay, there are multiple ways to calculate acceleration. You can use another 2 points, which is perfectly fine. You'll get the same answer. Okay, but once I find the acceleration, I only want the magnitude. Okay, because the sign just tells me that the acceleration direction is opposite to my conventional positive. This negative sign is not an implication for deceleration. Okay, and I will explain this in more detail. Okay, so back to the question. If you want deceleration, you find the gradient, which is the acceleration. Alright, the gradient got a negative sign. You don't worry about the negative sign. Right, you just take the magnitude. Okay, if this were positive, you also don't care about positive sign. Okay, you just take the magnitude, and that's the deceleration. And yes, the answer to your thinking is it is possible for acceleration to be positive and the object is decelerating. Alright, and I'll give you the answer, that case exactly in this question there. You see the acceleration here is positive, right? This type of graph I already told you is positive. You go and calculate acceleration here, it's actually positive. You'll come out positive, right? But is this deceleration? The answer is yes, because the speed here is slowing down. Alright, a very simple way to tell whether something is slowing down or not in the graph is to see whether the magnitude moves away from 0 or moves towards 0. Okay, so I'm going to show you how to see whether something is slowing down or speeding up. Okay, so we look here, this part, right? The number for velocity is going from 0 to 2.5 to 5. Right, remember that speed is the magnitude of the velocity. Right, so this is the magnitude, right? 5 and 2.5 and 5 is the magnitude of velocity. Also, so it's very clear that speed is increasing. Right, from here to here, I can say, oh, the object is speeding up. Right, I'm very happy with that. Here is constant speed because it's always 5. Right, then here I can see, hey, I'm going from 5 to 2.5 to 0. Right, since the magnitude of velocity is going from 5 to 2.5 to 0 and the magnitude of velocity is the speed, then I can say that the speed is going from 5 to 2.5 to 0. Okay. This is not the negative sign. This is not a negative sign. Please ignore. I was just trying to point out these numbers here, right? Then when I hit 0, what's the implication of velocity 0? It means I'm at rest. I'm stopping. My speed is 0, so I just stop here. Then when I stop here, then I realize my velocity go from 0 to minus 2.5 to minus 5. Alright, am I speeding up or am I slowing down? Remember that the negative sign in front of the velocity implies its direction. It has nothing to do with the speed. I repeat, the negative sign in velocity has nothing to do with the speed. If I want to know the speed, I just look at the numerical number. So I actually, if I want to just know speed in this region over here, right, I just know that the speed go from 0 to 2.5 to 5. Oh, sorry, it didn't go to 5, sorry. It just goes from 0 to some value, maybe 1 to 2.5, right? Because it maxed out at 2.5, right? It didn't go for 5, right? So I can say that in this region, I'm actually speeding up. Okay, Ken? And do you realize this is negative acceleration? Right? I told you already, this kind of shape is negative acceleration. So you have negative acceleration and you're speeding up, right? So what I'm trying to say here is that a common misconception students have is that negative acceleration implies slowing down. Not always true. Okay? Here, negative acceleration and slowing down. Correct. Here, negative acceleration but speeding up. Okay? And then the last part here. Alright? As I go from 2.5 to 1 to 0, right? I'm just looking at the magnitude because I just want speed. At this point, I just want to know speeding up or slowing down. This is clearly slowing down. Alright? So, part A, right, if I were to review, is speeding up. Part B, constant speed. Part C, slowing down. Part E, part D here, speeding up. And part E, slowing down. Alright? And that's how I answer this part over here. Describe the motion of the ship. Alright? From 0 to 50, the ship increase speed. Alright? Speed up. Right? From rest to 5 meters per second at a constant rate. Or you can say at constant acceleration. What do I have to describe the constant rate? Is because I know this is a straight line. Okay? So the straight line implies that the acceleration is constant. Right? From 50 to 150, constant speed. Okay? Why I bother to put a number here? Because easy to read off the graph. Right? From here to here, the ship decreases its speed, or you can say it slows down. Alright? From this to rest. Where's the rest? V equals 0. At a constant rate of 0.050 ms minus 2. How come I bother to calculate this value? Actually, I didn't. I just took it from here. Right? Since the question asked me to calculate earlier, alright, I'll just insert the value here. Okay? From here to here, it changes direction. Alright? Changes direction actually exactly at 250 right, where it stops. Right? If you go and look at the displacement diagram we used to draw to calculate these two parts, right, you realize that I changed direction exactly at this point, right, at this point over here where it's 250. Okay, right, so that's where I change direction and I increase speed. I speed up at a constant rate. Why is it a constant rate? It's still a straight line. Alright, it's still a straight line, and the magnitude of this gradient is still the same. It's still this one. It's the same. Correct or not? Right? Can you see the steepness of this line? This line is the same, even though one is slowing down, one is speeding up. Alright, so you can see that I can even write the rate here to be this rate. Okay, it's the same, but I didn't bother to write here Okay, if you put it in, it's not a problem, right? So yeah, maybe we are overkilling We already say change direction but to be very clear, a better response is in the opposite direction, because remember I told you that for graph you can only move in this direction and then you can move back. So change direction is a bit vaguish Is change direction this also change direction right? But this is obviously wrong, right? What I really want to express is opposite direction, so I would say this is a better term to use. Alright, so from t equals 300 to 320, the ship decreases its speed from 2.5 to a rest at a constant rate, and this one is still in the opposite direction. Alright, so that's how you do a description, right? In general motion of a ship, what we are looking out for is from the period to the other period, right? So let's say if I'm looking at this part from 0 to 50, is it speeding up or slowing down, right? Then after that, once you tell me whether it's speeding up or slowing down, you tell me the rate, right? That means you tell me the acceleration. Is it constant? Is it increasing? Is it decreasing? Okay, so that's the typical way we approach describing the motion of the ship. Alright, Ken, that's all for this part of the video.